Welcome to Module 2 of your AI journey. In Module 1, we laid the groundwork, exploring the fundamental concepts of artificial intelligence. Now, we'll dive into the practical side using Python to build your own AI applications. This module will equip you with the knowledge of essential Python libraries, powerful tools specifically designed for AI development. Let's get rolling. Imagine building a robot that can recognize objects, a program that predicts stock prices, or a language model that understands and responds to human language. Python, with its intuitive syntax and vast collection of libraries, provides a perfect environment for bringing these AI dreams to life. Let's explore the key Python libraries that form the bedrock of AI development: TensorFlow, PyTorch, Scikit-learn, NumPy, Pandas, Matplotlib, and Keras. Each library offers unique capabilities, catering to various aspects of AI, from deep learning to data visualization. Imagine starting an exciting woodworking project. You envision a beautiful table, sturdy chairs, and intricate shelves. But before you begin crafting, you need the right tools: saws, hammers, chisels, each designed for specific tasks. Similarly, in the world of AI, Python libraries are your tools, each offering unique functionalities to construct intelligent systems. TensorFlow and PyTorch stand out as the heavyweights for building deep learning models, the engine behind image recognition and natural language processing. Scikit-learn provides a versatile platform for traditional machine learning algorithms, perfect for tasks like classification and regression. NumPy provides the foundation for numerical computing, Pandas excels in data analysis and manipulation, and Matplotlib allows you to create compelling visualizations of your data. Finally, Keras acts as a user-friendly interface, simplifying the complexities of deep learning with TensorFlow. Together, these libraries form a comprehensive toolkit, empowering you to tackle any AI endeavor. Let's dive into the world of deep learning with TensorFlow, a powerful library developed by Google. Imagine building intricate neural networks capable of understanding images, processing natural language, and making predictions. TensorFlow provides the building blocks for these tasks, offering a flexible and scalable framework. At its core, TensorFlow excels in numerical computation, particularly with multidimensional arrays called tensors. These tensors flow through a graph of computations, hence the name TensorFlow. This graph-based approach allows for optimization and parallelization, enabling TensorFlow to harness the power of modern CPUs and GPUs for efficient deep learning. Once installed, you can leverage its vast collection of pre-built models and layers, or build your own custom architectures. Whether you're classifying images, translating languages, or predicting stock prices, TensorFlow provides the tools to build and deploy powerful deep learning models. In the realm of deep learning research, PyTorch shines as a beacon of flexibility and dynamism. Developed by Facebook's AI Research Lab, PyTorch prioritizes ease of use and experimentation, making it a favorite among researchers pushing the boundaries of AI. Unlike TensorFlow's static computational graph, PyTorch employs a dynamic graph, allowing for more intuitive model debugging and modification. Imagine building a complex deep learning model as if you were constructing a Lego structure. PyTorch empowers you to connect, rearrange, and modify components on the fly, fostering rapid prototyping and exploration of novel architectures. This flexibility makes PyTorch ideal for research settings where new ideas constantly emerge. Its intuitive API, closely resembling Python's numerical computation library NumPy, makes it easy to learn and use. From natural language processing to reinforcement learning, PyTorch fuels cutting-edge research in various AI domains. Scikit-learn, your go-to for traditional machine learning. While deep learning garners significant attention, traditional machine learning algorithms remain powerful tools in the AI arsenal. Scikit-learn, built on the foundations of NumPy, SciPy, and Matplotlib, provides a comprehensive library for tackling a wide range of machine learning tasks. Imagine needing to classify emails as spam or not spam, or predicting house prices based on features like location and size. Scikit-learn offers a plethora of algorithms for such tasks, including linear regression, logistic regression, support vector machines, and decision trees. Beyond algorithms, Scikit-learn provides tools for data pre-processing, model selection, and evaluation, streamlining the entire machine learning workflow. Whether you're a data scientist building predictive models or a researcher exploring new algorithms, Scikit-learn provides a reliable and versatile platform for all your traditional machine learning needs. NumPy, Pandas, Matplotlib, the data trio. Before diving into the complexities of AI algorithms, it's crucial to have a solid foundation in data handling. This is where the powerful trio of NumPy, Pandas, and Matplotlib comes into play. Think of them as the essential tools for preparing, analyzing, and visualizing your data, laying the groundwork for successful AI development. NumPy, short for numerical Python, forms the bedrock of numerical computing in Python. Pandas builds upon NumPy, offering flexible data structures like data frames for handling and analyzing structured data. Pandas excels in data wrangling, making it an indispensable tool for any data-driven task. Matplotlib completes the trio by providing a comprehensive library for creating static, interactive, and animated visualizations. Matplotlib empowers you to communicate your findings effectively through visually appealing and insightful visualizations. Keras simplifying deep learning with TensorFlow. While TensorFlow provides a powerful framework for deep learning, its flexibility can sometimes feel daunting, especially for beginners. Keras comes to the rescue, acting as a user-friendly interface that simplifies the process of building and training deep learning models with TensorFlow. Think of Keras as a set of pre-built Lego blocks for deep learning. It provides a high-level API that abstracts away much of the complexity of TensorFlow, allowing you to focus on the core aspects of model design. Keras's seamless integration with TensorFlow ensures you can leverage the full power of TensorFlow's backend while enjoying the simplicity of Keras's API. You've now added a powerful set of tools to your AI toolkit, equipping yourself with the ability to tackle a wide range of AI challenges. From building deep learning models with TensorFlow and PyTorch to exploring traditional machine learning algorithms with Scikit-learn, you've gained valuable practical skills. Remember, the journey of AI mastery is ongoing. Continuously explore, experiment, and push the boundaries of your knowledge. In Module 3, we'll delve into the exciting world of practical AI applications. Get ready to put your AI skills to the test and witness the transformative power of AI in action. See you in the next module.